Hey guys, hopefully everything's going well with you. We're going to start into our next unit. So it's a new tab up here called oblique triangles. Okay, so make sure you go to the new tab. This is really going to cover like Friday, Saturday, Sunday. It's nothing crazy, but we're briefly going to start into the next section. So this is on the law of sines. So the first two problems are kind of like a warm up, if you will. So if you want to take a minute and work through and find the missing sides on this, you could do Pythagorean theorem, set up a trig ratio to find your angles, etc. But the key thing I want to point out here is notice that you know for a fact that you have a right angle. Okay, so keep that in mind. The second question I do want to address though. So it says when given the following angle and side measurements, create a triangle labeling sides and angles appropriately. There's only one correct triangle that can be formed. So I want you to take a minute, think back to your geometry days, and think about what this triangle could look like. If you want to hit pause, take a second and do that. Okay, so hopefully, and this doesn't need to be like to scale or anything, but the key thing is hopefully oh my God, I can't speak. You remembered that the shortest side should be across from the smallest angle. So if I would put, my goodness, if I would put 48 degrees here, 16 inches better be across from it. Smallest angle, shortest side across from it. Like I said, my drawing is not to scale. The medium-sized angle should be across from the medium length side, and the largest angle, once again, clearly not to scale, should be across from the largest side. That's the key thing that I want to get at here. Okay, you can't just randomly place the angles and the sides wherever you want. Keep that in mind for where we're going to go in this chapter eventually. So this is the first part of the legitimate new notes. So when you look at this triangle, the key thing that you should notice is that it does not have a right angle marked anywhere. Okay, that's what's important about oblique triangles. And I had referenced this a couple times in our sessions with right triangles. So what I'm going to do here is I want to come up with what we're going to call the law of sines. This is kind of a proof, if you will, a mini proof, not like a geometry proof, of how we can get to that. So what I'm going to do here is I'm going to go and I'm going to drop an altitude down from B. Now, back to your geometry days, if you drop that down, you're going to get a right angle right here on each side. I'm going to set up a couple different ratios here for us. So I am going to look at, I'm going to call this my height, that altitude. I'm going to give it an H for height. And I'm going to say, I'm going to do two different things here. So I'm going to say sine of A, so this angle right here, is equal to the height over C for this little triangle that you have here. Right? At the same time, right, if this is this little triangle, I'm going to look at this triangle then. Now recognize those two smaller triangles have the same height. Okay, so keep that in mind. So now I'm going to look at, I'm going to use a different Greek letter here. Not that it really matters. Okay, ooh, hold on. Okay, so I'm looking at this angle down here. So I'm going to say sine of C is equal now in this one to opposite, so the H, over hypotenuse A in this right triangle. Okay, so what I'm going to do here is I'm going to solve each of these separate equations for H. So to do that here, I would multiply C over. So side C times sine of A equals H. Here, side A times sine of C equals H. Okay, now I'm going to, since they both equal that same height, I'm going to set these two pieces equal to each other. So I have C sine of A equals A sine of C. Now, what I'm going to do is I'm going to divide this side by C to get C over here on the denominator. And at the same time, I'm going to divide this A over here so that I have A in the denominator over here. So that's the first part of me proving the law of sines. So it basically says you don't have to have a right angle necessarily in the overall big triangle for this to work. But what that says is sine of A, so this angle A, over side A equals sine of C over side C, okay, of the big overall triangle. So at the same time here, let's do another kind of mini proof here. I'm going to now drop an altitude this way. And I'm going to be looking at these two smaller triangles. Okay, so now here I'm going to say sine of C, okay, is equal to h over b. Now in this big triangle here, b is the hypotenuse. Now let's look at this guy over here. Okay, let's do sine of b is equal to opposite, which is h, over c. In this triangle, the hypotenuse is this guy c. So same as before, let's solve those both for h. Now we can set these equal to each other. And then here I'll divide the b over here and the c over here. So what you should notice is we have a very similar equation like above. Now it's sine of c of the big triangle. So the angle sine of c over side c equals sine of b, angle b over side b. Well, these both have sine of c over c. Okay, so that means they're all equal then at the end of the day. Okay, so here, this is our law of sines. In any triangle, notice it doesn't say right triangles, the ratios of sides and their corresponding angles are equal. This right here is your law of sines. This is super important. Okay, this is used to solve any triangle when given two angles and a side. So when you think back to the triangles from geometry and when you did congruent triangles, so cases like ASA, you'd have two angles and a side, or AAS by two angles and a side. Okay, so let's look at two examples here and then one word problem real quick. So notice here, clearly triangles have 180 degrees, so we're solving triangle RST. So angle R, if we subtract from 180 degrees the 58 and 79, we find that angle R is simply 43 degrees. Now, okay, we had two angles and a side to start. We could easily find the third angle. There's only one choice for that third angle. But now we could do sine of R over side R. So sine of that angle 43 over the side length R, okay, is going to equal sine of, let's do S first, not that it really matters, so sine of 58 over side S. So we can cross multiply. S times sine of 43 equals 113 times sine of 58. So from there, we're going to divide the sine of 43. So you could punch in your calculator 113 times sine of 58 divided by sine of 43, and you're going to get that S is 140.5. Okay? We can do the same thing then for T. I'm going to stick to this guy with the R. So sine of R, which is 43, over side R, which is 113, equals sine of 79, that angle T, over T. Cross multiply. Once again, enter this in your calculator and then divide by the sine of 43, and you get that T is 162.6. Okay? If you want to try the next one on your own, go ahead and hit pause. When you hit play, I will be starting to put the answer here. Okay, so once again, we were given two angles. We can easily find the third. So now this is the relationship we're going to start with that we know. Sine of 34 over 74, they're the side length and angles that go together. I'm going to go for R next. Sine of 64 over R, cross multiply and solve, and you get 118.9. Same thing here, but now with the 82 inside S, cross multiply, and you would get 130.0 yards. Okay, so key thing, you started with two angles and one side to find this. All right, let's do one word problem. So now, this is a bearing word problem, but notice we might not necessarily have the right angles like last week. So it says two towers on an east-west line 7.2 kilometers apart. Spot a plane. Tower A sees the plane at a bearing of 71 degrees. So I'm going to put in my... Now the key thing here, okay, they don't have the whole east-west or anything like that, so it's just a traditional bearing from due north. Okay, so 71 degrees, okay, if I do the 71 degrees here, it's going to go this way. If I do the 9 degrees, it's going to go this way. So think about this. If I do the 71 degrees here, it goes this way. If I do the 9, it goes this way. We somehow need these to intersect. So if we would do the 9 here and the 71 here, they're not really going to intersect. Okay, so we want to do the 71 degrees here and the 9 degrees here. We're going to have to extend those to where they eventually hit. Okay, so maybe play that, rewind that and play that back again. Okay, so we want the 71 degrees here, so this is your A and this is your B. Now let's fill in some other things we know. So this is an east-west line, so that means these two angles together better form a 90-degree angle. So if this is 71, what's left for right here is 19. At the same time, this would also, just the dashed portion over, would be a 90-degree angle. So this whole angle here, 90 plus that 9, would be 99 degrees. So we can take 180, subtract out the 19 and the 99, and we find that this angle right here would be 62 degrees. Okay. So how far is the plane from each tower? So ideally, we need to find this and this. Okay. So we can say sine of 62. Okay. We have two angles. We actually have three angles, and we have one side length, so we're good to go. So sine of 62 over the side length across from it, 7.2, equals sine of 99 over y. You can cross multiply and solve there, and you would get that y is 8.1 kilometers. Okay, let's use that same ratio of sine of 62 over 7.2 equals sine of 19 over x. Okay, because the sine of 19 is across from side x. Cross multiply, and you would get 2.7 kilometers. Okay, so the key thing is understanding which one is the A and which one is the B. Okay, so the fact that if this were 9 degrees, it would go this way, and if this were 71 degrees, it would go this way, and those wouldn't ever really intersect for the plane. Okay, so you need this to be the 71 and this to be the 9, so they eventually do intersect there. Okay, you will have some practice problems from the textbook to complete after this. Please let me know if you have any questions. Next Tuesday, the teachers have in service, so I won't be giving out any new assignments. So I will hold office hours on Monday for questions related to this. Please reach out if you need help at any point. Have a good one, guys.